convert the following points from rectangular to polar coordinates. First point, xy equals 0 minus 3. Now, we sketch the point in the plane. So we're going to go over 0, down by 3, and then you could pretty much get the polar coordinates by observation. So in this case, I measure off of the positive x-axis. We go around by 3 pi halves. So that's going to be my theta. Then we take the ray coming from the origin along 3 pi halves. I'm going to go down by 3. So that's going to be my r. So r is equal to 3. So in polar coordinates, our point's going to be 3 comma 3 pi halves. Now, that's too easy, so let's check it with the equations. First, we'll have r equals square root of x squared plus y squared. So we'll put in 0 minus 3. That gives us a square root of 9. So out comes a 3 for r. So that checks our 3. Then for the angle, okay, I want to use x equals r cosine theta, y equals r sine theta. Divide both sides by r. That gives us cosine theta is x over r, sine theta is y over r. So in our special case, cosine is going to be 0 over 3. That gives me a 0. Sine theta is going to be y over r, so it's going to be minus 3 over 3, gives me a minus 1. So cosine and sine, it's going to be 0 minus 1. And that's going to be the point down here at theta equals 3 pi halves. So that just checks our angle. Okay, another check. Let's take our r and our theta and put it into our equations for x and y. So x is going to be equal to 3 times the cosine of 3 pi halves. So if 3 pi halves is down here, the x value is 0, so out comes a 0. For the y, we have r sine theta. So it's going to be 3 times the sine of 3 pi halves. Okay, if we're down here, the y value or the sine is minus 1. So we have 3 times minus 1 is a minus 3. So we get rectangular, 0 minus 3. And that checks our original point. Next point, this one's a little bit tougher. xy equals minus 4 comma 4. So if I plot my point in the plane, I'm going to go back 4 and then up 4. Again, I can get this one pretty much by observation. So if you note, we're on the line y equals minus x. So we're going to have 45 degrees, 90 degrees. Our angle is going to be 135 degrees or 3 pi over 4. To get r, we just draw in the right triangle. So we'll put in the hypotenuse, going from 0 to our point, and then just put this side in. So r is going to be the length of the hypotenuse. This side is length 4, this side is length 4. So r squared equals 4 squared plus 4 squared, or r is equal to square root of 32. Factor out the 16 is a 4, so we get 4 square root of 2 for r. So our point's going to be 4 square root of 2, comma, 3 pi over 4. Now, of course, we want to use the equations, so that'll be the check on our work. Now, r is going to be the square root of x squared plus y squared. So we're going to have square root of 16 plus 16, square root of 32, or r is equal to 4 square root of 2. So that's what we got before. Then we're going to use our formulas for cosine and sine. So cosine is going to be x over r, sine is going to be y over r. Cosine is going to be minus 4 over 4 square root of 2. We get a minus 1 over square root of 2. To make that familiar, I multiply by square root of 2 over square root of 2. Then I get minus square root of 2 over 2. So reference angle is going to be pi over 4. For the sine, same idea. We have 4 over 4 square root of 2. I get 1 over square root of 2. I multiply by square root of 2 over square root of 2. And then we get square root of 2 over 2. So note, we know the reference angle is going to be pi over 4. We just need to figure out the quadrant. So the cosine is going to be negative. Sine is going to be positive. So cosine is the x value, which is negative. So it's going to be back here. The sine, which is the y value, is positive. So it's going to be up here. So I have to be in quadrant 2. The multiple of pi over 4 that's in quadrant 2 is going to be 3 pi over 4. So that checks our angle. Then the final check, we put r and theta in to our equation for x and y and just make sure we get the same rectangular points back. So if I put r and theta into the equation for x, so it's going to be r cosine theta, out comes a minus 4. And then for y, we have r sine theta, out comes a 4, and then that checks our rectangular. Next point, let's try xy equal to 3 comma minus square root of 3. This one we won't be able to get by observation. So let's just follow the equations out to get to our answer. Now, r is going to be square root of x squared plus y squared. So we'll have 9 plus 3. That gives me a 12. I can factor out a 4 as a 2. So r is going to be 2 square root of 3. Then, if I want cosine and sine, we have x over r, y over r. So for cosine, we're going to have 3 over 2 square root of 3. Now, the way I can simplify this, we have two options. One, you can write 3 as square root of 3 times square root of 3. Square root of 3's cancel, leaving you with a square root of 3 over 2. Another way, you can multiply by square root of 3 over square root of 3. You'll get a 3 in the bottom, and then the 3's cancel. And you're left with square root of 3 over 2. Then for the sine, we have y over r, so it's minus square root of 3 over 2 square root of 3, and then I get minus a half. So we have our cosine and our sine. So we want to get the angle, so I'll need the reference angle and the quadrant. Okay, the quadrant's going to be easier, so we'll do that first. So we're going to have a positive cosine, a negative sine. So cosine's the x value, so it's going to be over here. Sine is the y value, that's negative, so that's down here. So that's going to mean we're in quadrant 4. Then for the reference angle, we have the cosine equal to square root of 3 over 2. That's roughly 0.87. Now, we know our reference angle, because we have these two values coming out, is going to be either pi 6 or pi thirds. We want the one that has the larger cosine. Okay, that's going to be the 0.87. Now, the one with the larger cosine means bigger x value, and of those two, that's going to mean the one with the shorter angle. So that's going to mean pi over 6. So our reference angle is pi over 6, so we want the multiple of pi over 6, that's in quadrant 4. That's going to be 11 pi over 6. So our point in polar coordinates is going to be 2 square root of 3, 11 pi over 6. Again, we do our final check, put r and theta in our equations for x and y, and then out comes 3 and minus square root of 3, so our work checks out.